So welcome back. Student, how many of you have worked in a company, like as an intern or part-time in an IT company? Have any of you has worked in an IT company? So I'm planning to show you some, it's a spoof or a kind of joke YouTube video. Are you interested to watch 2-3 minutes of YouTube video? Would you like to watch interesting YouTube video, which is a kind of joke, but that kind of situation is real for many interns. So let's see. So this is a guy who is doing study in the Canada, and he has this YouTube channel, and someone shared with me. So let me share the sound. Okay. So let's go.
Hi, hello.
Hey, how's it going?
Yeah, pretty good.
Okay, so welcome to the company. It's your first day. I will help you on board. So the first thing you want to do is download the code base. So go ahead and clone the Git repository. Can you see my screen?
Yeah, now I see it.
Easy, I know how to do this. Alright, so now you want to go ahead and install npm node git VS Code, or you can use any IDE you want. Then you want to use your email to sign into Confluence for documentation, Azure DevOps, Jira, and GitHub. You got that?
Yeah, it's just downloading.
Yeah, perfect. So we're a pretty diverse company. We use multiple technologies here. So you want to go ahead and also install Python, Java, C#, C++, Selenium. And once you get that code base set up, you want to go ahead and use the command line to directly install Linux, TypeScript, JavaScript, and set up the configurations. I won't show you that because, it's just, it's pretty simple. So yeah, do you have any questions?
Yeah, I think your screen is lagged.
Alright, so no questions. Perfect. You seem to be pretty bright. I'll give you your first task right away. It's pretty basic, just to get your feet wet. So basically, you're gonna fix this button.
Oh, okay, that's not too bad.
And then you want to make this button interact from front to back end. It should make exactly 7.5 API calls and return the data to the AWS Cloud WordPress, which is our middle end. But you want to make sure it doesn't bottleneck, so add some multi-threading in the JavaScript. And are you familiar with machine learning?
No.
Yeah, you probably are, right? You kids are really good with that stuff nowadays. So maybe just add a little bit of unsupervised classification, and we can, cluster the HTML attributes. And if you really want to go above and beyond, you can also use Bootstrap to strap everything together at the end. Just pretty simple. I have to jump on another call, so don't hesitate to ask me if you have any questions. And you'll be done with this in like 1 hour, right? So I'll see you then. Good luck.
So how was it? How was it? So my lectures might appear like the same thing, the way his supervisor in the company was talking. So if that happens, then do let me know that I'm going too fast or having too much. So let's move back to our. Thank you. But this kind of thing can happen. I did ask some of the students from Indian community who has gone to Amazon or Facebook. 1 or 2 students has similar experience, like they have been treated like they know everything. So don't worry if you see my lectures are going like that, to remind me. So hypervisor. So what is hypervisor? So hypervisor is basically a software, or you can call it a firmware. Firmware I might cover another day on Friday lecture if you are not aware of what is a firmware or difference between a software or firmware. But hypervisor is basically a software that creates and run the virtual machine. So basically, with the help of hypervisor, we are able to virtualize the hardware beneath, and then the virtual machines can be created on it. And the virtual machine, if you are creating, then it needs to be managed. So hypervisor, sometimes also called as virtual machine manager. Hypervisor can be of two types. One is a type 1 and another was a type 2. Type 1 is known as a bare metal or native hypervisor, and type 2 is known as hosted hypervisor. So type 1 is the if you go to work in any company and they are using the virtualization, it is 100% they are using type 1 virtualization. So every company uses the type 1 virtualization. Now question arises, when do we use type 2 virtualization? Type 2 virtualizations are basically used for testing and learning purpose. Like if you want to create a lab or something and you do a cloud computing lab, like using OpenStack, then we had been using this type 2 hypervisor way to do the lab. Or if you are developing some software which runs on the cloud and you need to get it tested, then in the testing environment, the type 2 hypervisor is used. So what is the difference and how type 1 is different from type 2? We will come to know a little later in the slides. So type 1 hypervisor, basically if you see the figure, so below is a hardware, and which is a host, or you can call it a server. In a virtualization world, it is called a host. Then on top of it, there is a hypervisor, which is a virtual machine management software. And on top, the VMs are created. And on the VM, the guest operating system and then other application and software can be installed. So like that, many VM can be created. So how they are connecting with the internet, they actually connect, if any resource they need, if they want to connect from this VM to this VM, they have to actually go via, get the service via down. So even if they want to connect to the internet, they have to go via this way. Just the VMs are not directly connected to internet. It is connected to internet via the host below. So the host is connected to everything, and anything VM need, it has to request from the host below via this virtualization software. So by figure, it is quite explained, and this is a type 1 hypervisor. So type 1 hypervisor run directly on the system hardware. Means if we are getting, we want to convert a system into a virtualization, then we have to, before installing any operating system on the hardware, we have to install the hypervisor. And hypervisor can be VMware, can be Hyper-V, or can be any other hypervisor. So when a system is completely blank, that time the hypervisor is installed, right? And the guest operating system can be installed on the hypervisor, but in hypervisor itself has a very small OS operating system is there. But on VM we install the operating system, which is a guest operating system, we call it. So if we are installing an operating system, like we created a VM and we installed the Ubuntu or we installed the Windows, then basically that time that operating system is basically a guest operating system which is installed on the VM, not on the hardware beneath it. VMware ESXi is a type 1 hypervisor. It is a type of software suite which can be used to hypervise or virtualize the hardware beneath it. And this runs on the host server hardware without any underlying operating system. So when we are installing ESXi here, there was no operating system installed on the hardware. So it is a completely blank or bare. So that's why it is also known as bare metal hypervisor, that is called without operating system. And type 1 hypervisor is basically a firmware. There is a slight difference between a software and a firmware. So firmware can directly interact with the hardware, and when like you have a USB device, etc. So when you connect a USB device to any system, the USB device had a small chip in his chipboard, and also a small memory. In that memory, there is drivers are there, and those are called firmware, by which you connect to any host, your USB. The host is able to understand what it is if the drivers or hardwares are not installed on those host. Nowadays, there is a standards are there. So, and for Windows system, if you connect USB, you don't need to errors don't used to come. Earlier we need to install the driver, etc. But nowadays the Windows, etc. has firmware for almost all the major USB makers. And guest operating system can be anything. So on this VM, I can install Windows, and this I can install Linux, and this I can install Mac, or any CentOS or NetBIOS, or any kind of operating system we can install independently on a different VM. So this gives some flexibility, a lot of flexibility. So as I was saying, that this VM, if it has to do anything, it has to interact or ask the service from the hardware below. If he wants to connect internet, so all this requests will go from here. Anything it want to do from outside world, it has to go from here. If it wants to connect to here, then it has to go here, then go here, then it gets connection to this. And this is can be done by a software called ESXi. So it is elastic, scalable, getting connected to internet. So that is the name of the VMware software. ESXi is a software name for doing the hypervising. Now, how the type 2 hypervisor is different. So if we compare the figure, so hardware is there, and on top the hypervisor is installed, and then the VMs are created. But in the type 2 hypervisor, you have a hardware, which is a virtualization host. On top, you have an operating system. Like if I want to virtualize my laptop, it will have the Windows or a Linux or a Mac operating system. So it will have an operating system, which is a host operating system. And on top of it, if I install this ESXi, then it is a virtual machine management software. And then I can virtualize my laptop or desktop hardware behind it into a VM. And on the VM, I can install the guest operating system. But in type 2 hypervisor, we have to install the same OS what is below. We won't be able to install any other OS on there. So it is that way different because it has so many layers, and there is already OS there. So it says that type 2 hypervisor runs within the conventional OS environment and the host OS provides. So what are the example of type 2 hypervisor? So VMware Workstation. So if we want to virtualize our laptop, then this VMware software we can install on our laptop. Then our laptop will be virtualized, or we can install Oracle's VirtualBox or Microsoft Virtual PC. And so, but this way it does not have a direct access to host hardware and resources. Like if the VMs are created here, it is not directly interacting. It has to the virtual machine management software like Virtual PC or VMware Workstation or Oracle VirtualBox has to send the request to the operating system below, which is a host operating system, and that is going to ask the request to the hardware below, and then that service will be provided, or whatever resource it wants will be provided. And so type 2 hypervisor is a software, it is not a firmware. and it is a hosted type of hypervisor. So type 2 hypervisor is also known as a hosted hypervisor, hosted virtualization environment. You see, in this case also, this VM is actually completely independent from this VM and that VM. So even in case of type 2 hypervisor, they cannot interact with each other without taking requests from here or making the services. So our desktop, we can create, let's say it has a 4-core system, we can create 3 virtual machines, each can have 1 core, and we still can do all the colloquium what we did, like making a virtual network, interacting one virtual network to other virtual network, like within a single zone, because that time it will be within a single zone. We cannot do a region-wise virtualization colloquium, but still it is possible to do the labs for cloud computing and big data or virtualization concept. So as we see that they are pretty safe. They do not interact with each other. They actually don't have access to each other. So if we want to compare between a type 1 and type 2 hypervisor, so type 1 hypervisor is basically a bare metal or native hypervisor. It is also known as, but type 2 is known as the hosted hypervisor. If we want to understand in terms of virtualization, type 1 is basically a hardware virtualization, while type 2 is an operating system virtualization. In type 1, the guest OS and application run on the hypervisor, but in type 2, it runs on the application on the host operating system. So the OS here is running on top of the host operating system. The type 1 has a better scalability, but type 2 not much, because whatever the underlying operating system will provide, it has to rely on that. So whatever below has a capability, that much only it is able to do it. It has a direct access to the hardware, so the system lag and dependency is low. But the VM here that does not have a direct access to the host hardware and resources. Performance-wise, type 1 hypervisor has a very high performance because it has a direct access to the hardware. But comparatively, the type 2 will have a low performance because it has to go through the additional overhead. So it is a slow in response compared to the type 1. Type 1 is more secure because it is directly interacting with the hardware and there is only virtualization layer, and whatever security virtualization layer provide, all the VM on top of it will have that security. But the type 2 is vulnerable as the host operating system, whatever vulnerability will be there, it will be passed on to everything above it. So any problem in the base OS will affect the entire system and all the VMs. Examples are there like VMware ESXi by VMware, then Hyper-V by Microsoft, the Zen server by Citrix. So Citrix also make the hypervisor, which is known as Zen server. Type 2 hypervisors example is VMware Workstation, Oracle VirtualBox, and Microsoft Virtual PC. What are the types of virtualization? As we know that there are many types of virtualization. There are data virtualization, desktop virtualization, CPU virtualization, network virtualization, storage virtualization, and server virtualization, and many more virtualization. So we are going to cover only a few of them. What is a data virtualization? So data virtualization is basically analogous to data agility, in which an application is allowed to access data irrespective of its technical detail, formatting style, or physical location. So there are example tools are there like Red Hat, JBoss, or Denodo. So this tool can be used to do a virtualization of data. So in that case, by doing the data virtualization, an application can access any data in any format. So they take care of the whatever required to make it happen. So like in below, you have more structured data like SQL data. You have the disparate data. You have less structured data like NoSQL data, web data, web logs, XML data, Excel data, PDF data. But then using the data virtualization software, that the application on top of it can able to access every type of data, and it can data consumer can be a business intelligence, can be a mobile user, web user, or for reporting purpose for any enterprise application. So there are many other data virtualization softwares are there, and Red Hat JBoss and Denodo are a few of them. Then comes the desktop virtualization. So desktop virtualization I have seen since 2003 when I first started working in IBM. I have to work on a thin client. So IBM has a computer called a thin client, and in that time only a screen was there and a keyboard was there. I was very surprised that where is the CPU, because I used to see CPU, but what I got was a keyboard and a screen and the login ID and password. They say that by this you can connect to the virtual desktop and everything is there. In fact, using our AD account, we do get our virtual desktop in whatever system we access from the UIT. So this is a type of desktop virtualization. By using that, a virtual desktop can be created, and there is a virtualization layers is there on top of hypervisor that provide the desktop provisioning. So architecture-wise, it's like there are desktop, thin client, laptop, mobile, and they are so VMware has a software called VMware View Manager, and VMware Sphere, which is a vSphere server. VMware server is there. If that is installed on the server, then people simply can access their virtual environment, virtual desktop, just by keyboard and a screen. They no need to have the expensive anything. So nowadays, many companies work in that. So that's how they are utilizing their resources more effectively, and data protection is also there. They can have more protection because direct access to hardware is not there. So it is giving a lot of benefit to the company. People can be anywhere, and then the software is able to take care of all the needs, firewall, everything. So then we have already seen some example of CPU virtualization. So it allows a single processor to act as a multiple individual CPU. Like let it behave like two separate systems running on single machine. Objective of CPU virtualization is to allow the user to run different OS simultaneously. I have the hardware which has a CPU with a multiple core, and then I virtualize it. So in each of the core, I create a VM, and on the VM, I can install any operating system I want. So if I have 4 core, then I can create a 3 VM, and I can put the virtualization of OS like Linux in one, Windows in other, Ubuntu in other, or Mac in other. So that's the called a CPU virtualization. It helps to run a different OS simultaneously. How it helps, like when we are developing a software in an industry, and we want to know that it can run on many all the different type of operating system the user has for the company. So by using this CPU virtualization, a different OS can be installed and that app can be tested. So they don't have to go and find the different kind of OS or a version number. Like you want to test Ubuntu 10.1 version, okay, create a VM and install Ubuntu 10.1 and then run on it. You want to test Ubuntu 9 version, okay, create a VM and install Ubuntu 9 and run on it and test whether the software is functioning or not. So it is giving a quite flexibility for the industry to have something well and running, effective. So as I said, CPU virtualization is basically we have a physical hardware, and on top we have hypervisor, we can have kernel and scheduler, and there is a virtual machine manager. On top we can create VM, install app, We can install one type of OS, and we can install another type of OS, install another type of OS. So this is what how the CPU virtualization architecture look like. Then comes the network virtualization. We have seen certain on Friday. I have shown you that subnetting, that is one way of doing network virtualization. So by doing network virtualization, it creates the virtualized combination of available resources. So it split up the bandwidth into channels so that each device or user can have shared access to all the resources on the network. In network virtualization, hardware and software network resources and their functions are encapsulated into a software-based administrative entity. So basically, one software encapsulation is there that is allowing the network virtualization to happen. It can, by that encapsulation, the network bandwidth can be shared into channels, and all the network functionality can be virtualized by using network virtualization. So basically, we have a physical network, like one network port is coming, and on top of it, there is a internet protocol transport layer is there, and the network virtualization platform is there on that IP transport layer. Remember, we have studied the 7 layers of OSI model. So this is a transport layer, and then using this, we created a virtual network. We have done in our colloquium creation of virtual network. Virtual network can be in different layers like L2, L3, L4 to L7. So in OSI model, there are 7 layers are there. Virtual network can be created in many layers. Depending on which layer you are creating, the type of functionalities will be available, and then workload will be on top of it. So this is how the same physical network can be virtualized and being used for different purpose. If you are using in L3 layer, then a different purpose is there. In L4 to L7, we can have application, session, other activity, which we have seen in the OSI layer lecture on the Fridays, few weeks before. Then comes the storage virtualization, as we saw the example of mobile phone or the NASA example, that physical storage can be assembled from various resources, like we can have 1 GB USB or 512 MB SSD or 512 GB SSD. Everything can be pulled together to create a large pool of memory, and after that it can be managed centrally, so via the storage area network. So SAN is basically a different from network area storage. So when we virtualize the storage, then it is known as storage area network, and while it can be managed centrally, if someone needs some storage requirement, then this centrally managed network can provide the storage. So in the example which we saw, the mobile phone internal and external memory, after the external memory been allowed to behave like an internal memory, so we virtualize it, and that all the space available like 32 GB and 16 GB, which is a 48 GB, that is available via the centrally managed storage area network. So in terms of server virtualization,